Hi, everyone. Thanks for being here. I'm Evan, one of the co-founders of Mina. We've been working on Mina for a very long time now, since 2017. And I wanted to share kind of what we're learning in this recent stage of the project. We're working on bringing computation onto the chain. There's a lot of really interesting little insights and things that we are figuring out. So kind of half update, half kind of interesting lessons about building this kind of ZK protocol. I think for this group, this probably isn't necessary strictly, but a quick overview of maybe at least one framing of how to think about zero-knowledge proofs. They're a way of taking a computation and having a proof about what the result of that computation is on potentially hidden inputs. So that's really cool because it gives you privacy applications. And it also means you can have verifiable computation. You can have large computations that you can have proofs of the result of very succinctly. There's a lot of different applications of this, but one application of this is recursive verification of blockchains. So this is what Mina set out to do originally, and has done, but way back in the day, which is this idea of taking the operation of verifying a blockchain, where usually you have to download all the transactions, you have to process them locally, all of that, and replacing that with a recursively updated zero-knowledge proof that you can then check, and that stands in for that process of downloading everything and checking it, because you know there exists a valid path from Genesis to where you are now that attests to the state of the chain. And so this is really cool because it means that you can have blockchain proofs that are very, very small, measured in kilobytes. In Mina's case, it's around 11 kilobytes or so for the proof plus a few other things. And it also means that the chain can have lots of transactions being processed, but the chain stays the same size. So there's a sustainability property as well, which is very nice to have. It also means that it's going to be minutes to sync a node instead of I think in the order of weeks and months for today's blockchains. Mina today, the Rust node syncs in less than 5 minutes still, which is very cool that it still does that. And it also means that you can run these full nodes on browsers and on mobile, so you don't need RPCs, so you don't have to worry about other parties being involved that could potentially censor the system, or otherwise you can connect directly to the network. And here's a GIF kind of showing, not a GIF, but the recursive image showing kind of what's happening in Mina and these recursive systems. You have a snark, which is itself verifying the last snark, which is itself verifying the last snark, recursively kind of all the way back to Genesis. So it's kind of a cool, and at the very kind of back of that, there's a Genesis block somewhere. So it's kind of a cool recursive construction of how you can make these kinds of systems verifiable. So basically, this is what Mina launched with its 2021 mainnet for payments only, but this is what the original one looked like. And it's been quite a while, but the in-browser and on-mobile full nodes are finally entering some kind of public testing. We just are kicked off a live public test with on the order of 100 or so people from the community for testing a full Mina node in the browser, which also will do block production, which also does block production, which is pretty neat. You go to a web page, takes a few minutes, and then you have a full node running in your browser that's connected using WebRTC to other nodes. So very decentralized. We're imagining eventually that living in an extension or something of the like, where you can get this fully decentralized access from your local device. And that's cool and all, but when we launched this was only for payments, and what we really wanted to do was do this for general computation. So you can imagine not just having this decentralized node, which you can send payments with, but also build kind of any kind of application. And those applications being, because they're on this network, extremely decentralized, something that really kind of goes a step beyond what a lot of the systems today can do. But that's a lot of work, because adding payments means kind of adding a fixed set of formats. But adding general computation, of course, means supporting any kind of computation that you would want. So that's a bigger project. So we've been working on that since then. And really, what do you want to be able to do with this? For one, we do want to be able to settle general purpose computation onto Mina. We want it to be relatively easy to do that. And we also want use cases around kind of the fundamental functionality of zero-knowledge proofs, such as privacy, such as verifiable computation, et cetera. And also another cool property you can have is this property of recursive scaling, which we'll talk about in a bit, but means you can have a much higher throughput of things running on this network than otherwise. So the first one of these is done. We launched an upgrade adding ZK apps to Mina mid last year after a lot of work. But what we've kind of learned since then is doing all these things right in a way that actually makes them like super easy to use and actually gets the functionality out in a way that is very accessible and usable is requiring more work. And that's what I kind of wanted to talk about today. Kind of like what got built into the layer 1 of Mina, and then what is it that you kind of need on top of it that I think we suspect that most ZK chains are going to need in some way or other. And so hopefully it's more broadly relevant too than just Mina. Just briefly, Mina's proof system. It's called Kimchi. It has a layer on top called Pickles, which allows for very efficient recursion on top of it. So this is proofs that verify other Mina proofs that can verify other Mina proofs, et cetera. And that's how, of course, Mina itself is able to make its very small blockchain. And there's some important properties around it. Kimchi is, exists in a lot of different formats and a lot of different places, including WASM. So you can make proofs in the browser with it. It also, of course, has good functionality for privacy things as well. And also the recursion property, as well as it has this property of succinctness, means the proofs are very, very small. So you can do a lot of different computations and proofs and kind of fold it together into one small proof. And now let's zoom in on the layer 1 and talk about what we actually added to make general purpose computation a thing on Mina. So we've kind of talked about this succinctness already, but I think the key thing to talk about that we added was Mina's account-based, so you can send payments between accounts. What we did was we added to each account a verification key option. So you can load verification keys into accounts, and then the only way you can interact with those accounts is by having proofs be submitted that pass with respect to the verification key in the account. So it's kind of very general purpose. You can really, if you want, kind of load any general purpose program into an account, and then you can have it operate over some state, both in the account as well as elsewhere in the system. And what this kind of looks like from a development perspective and what's actually happening on chain is a model where you can basically, in these proofs, have preconditions and side effects. And so you can say this verification key means that I only accept proofs that accept balances of exactly 5 Mina being sent to this account. Otherwise, we don't accept. And side effects such as managing the payments that are flowing through the system, as well as modifying state, et cetera. So that's very powerful and very flexible, but it has a limitation, which is that if you have 2 transactions, which the side effects modify the state such that the preconditions don't necessarily pass, then you can have situations where 2 transactions cannot be submitted at the same time because they kind of clash with each other. You can imagine this, for example, in the context of a DEX trade where transaction A moves the price too much for transaction B to be able to be allowed past. And that's a fine example, that's acceptable. But another example is that a lot of applications have specific state, like for example Merkle trees in them that they need to be able to operate over. And it's not a good property, unfortunately, that when you have transaction A modifying a state like Merkleized state, for example, that then transaction B will not pass because the preconditions on the initial state of the application don't match anymore. So you're in this situation where the system almost becomes UTXO-like if you want to have multiple transactions occurring that have kind of more complicated side effects and preconditions, which you very frequently do. So general purpose, but you have this UTXO-like model. I think, so one of the things we've kind of realized since then is that we do think it's probably right in some ways to have this kind of agnostic layer below, but you need something on top that makes the system able to handle more robust kinds of transactions and kind of get out of this UTXO-like model into a more normal kind of account-like one. And that's a lot of the work going on Mina today, is building these verifiable app chains and L2 rollups that settle to Mina. So it's cool because you kind of can write your application in ONJS, kind of fully verifiable. And then what happens is that can then create proofs which then fully settle to the Mina layer 1. So the Mina layer 1 is then able to say, here is like a full proof that the recent history, like all the recent transactions that they want to roll up into this account are valid and accurate and are as expected and everything. So Mina layer 1 in this world becomes this kind of settlement layer for these rollups and app chains that also provides a layer for like kind of bridging and messaging and token transfers between these different applications. Kind of like this UTXO layer that sits over like these more customizable application environment layers. You get a lot of other interesting benefits from this too. For example, you can have each app chain or rollup itself have a lot of transactions in it for high throughput. So you can scale the system this way. So you can have each app chain doing a very high 10, 20 TPS each, and then that folds into one proof that gets settled onto Mina. And so you can have many different applications that are all doing relatively high throughput while having this full verifiability property. There's a lot of other benefits too for this. Like for example, you don't have to have the proving be done client side. Proving can be done on the actual application environment servers themselves. So that means you can avoid as well things like having to wait for a proof to be constructed locally on your device for non-private applications too. So this I think is like one big learning was like, it's pretty limited what you can do in kind of this UTXO model, but it does mean you get this like really awesome like flexibility over building different app chains and rollups on top, which is very powerful. And I'll talk about that. What's being built there exactly later, but we suspect this is kind of a missing layer that will make it a lot easier to build things. And then the last thing kind of on top of this is actually devices creating private proofs for submission to the layer 1. So for that, we have this library ONJS, which I think I mentioned briefly before. And that, of course, allows for privacy and everything. It also runs in WASM, so you can run it locally on devices. And it also, it's not a ZK VM. It directly compiles your TypeScript. You use the TypeScript library to like write the logic of your code, which then gets compiled directly into a circuit. So it's very fast and efficient. Fast enough to run, yeah.
To build a compiler?
Yeah. So the way, in the ONJS logic, you import like the library, and then you're doing like x equals like new zk integer basically, then x.add b, and then like you're kind of, as you write the code, you're dynamically constructing like the logic of your program, which then gets compiled and proven, et cetera. If that makes sense, yeah. It's cool because you stay in TypeScript that way, and everything's npm. There's no like new tooling or anything, but it's directly constructing these circuits, which can be very efficient, and it has a lot of other nice features like this WASM tooling and everything. So that's great, but it has its own issues as well. Particularly, WASM is very limited on mobile. You only get, depends on the device, but anywhere between 1 and 4 gigabytes of RAM, which is like often not good enough. So that's like a big limitation as well that I want to talk about. So I think, like there's these two big learnings, I think. For one, like we suspect that like most applications, most ZK chains are going to need some kind of application environment. This can be baked in at the layer 1 itself. Like for Mina, for example, it already has this preconditioned side effect system, which you can think of as an application environment. But we suspect there should be many kinds of application environments that allow for many different kinds of functionality to really, create the environments that people need with zero-knowledge proofs, while also being like sufficiently flexible and powerful. There's really 3 kind of under construction now for this. First is like this one called ProtoKit, which is this concept of verifiable app chains, and that's on Lightnet now, and it's not on DevNet or testnet. DevNet will be soon, but you can use that to kind of code these verifiable app chains that do around 10 to 20 TPS, and are pretty easy to write. They have like key value stores and abstract away a lot of the challenges of directly writing zero-knowledge proof applications, which is really awesome. There's one called Zecco, which is actually entering testnet now, and they're undergoing a security audit at the moment. This is actually an isomorphic Mina L2, so they've taken the exact same logic of Mina, and they've rewritten it as an L2 that itself settles to Mina, which is fun because you can write an application for Mina L1, and then you can just point it at Zecco, and then you can get nicer features because they're in L2, they're able to like add things like instant finality, for example. They're able to have higher throughput. They're able to have some nicer features on top, which makes it a little less UTXO-like in certain cases. So there's that one as well. And there's also some other projects that are being exploring kind of settling to Mina, where you still get to write all the application logic you want and do all that, but you can take advantage of the settlement and security provided by the layer 1 of Mina. And then I was kind of mentioning this a second ago, but there's definitely more work needed on client-side proving. It works, which is already pretty cool. But a couple big issues with it. One is that definitely needs more optimizations on the proving side. It is slow, especially in WASM on mobile. As well as we have this like memory limitation we run into a lot of the time. And I think for both of these really, an approach that we're exploring is natively compiling the Rust kimchi prover into iOS and Android libraries that can then be directly imported into the wallets that people are using on Mina, on the wallet mobile apps on Mina. And you can both get access to like the native proving speed and everything on that, as well as more memory usage and everything. It just makes everything a lot easier to work around and reason with when you don't have everything being in WASM. I think there's also meta learning here, which is like, this is kind of complicated, putting all these different layers of the stack together. And I think that like we're thinking internally, how do we better consider all these different implications of like the settlement layer, the application layer, the client side layer, and how does it actually factor into like what an actually good experience looks like for an application coming out of all that. Basically, like what can we do coordination-wise to make this better faster? Because it's complicated and there's a lot of moving parts and people working on whole different parts of the stack. Just to have an example which kind of pulls this all together. There's a library being worked on right now called Mina Attestations, actually also in like the security audit phase, and they'll be out in a few weeks, where you can have credentials that you store in like your wallet, so they're secure from websites, so that the website doesn't see your passport information or your credential that says your KYC information, et cetera. But you can make proofs in the wallet and then send them to the web page. So kind of a secure way of creating proofs from credentials and then giving them to web pages to use. And there's a little language in there for privately proving the credential in the wallet, which then creates a little proof, which can then be sent to a ZK app chain, like ProtoKit, like we can imagine, which then itself bundles everything up into a single proof that then ends up on the Mina layer 1, which then can be interoperable with other things settling onto the Mina layer 1 and other things happening on it. And then Mina itself is bundling that all together into a zero knowledge proof that then gets sent out to like client devices, full verifiability of kind of the whole stack. But you can imagine, this can have a lot of different privacy information as well as more complicated logic. Like maybe this is like a proof that you own a company email address to participate in like a vote that's only eligible to people from that company that is private, et cetera. So you can kind of see maybe how this all kind of flows together. You write all this stuff in TypeScript, and it all creates proofs going all the way down until it ends up on devices that can then verify the state of the system. So there's a lot happening on Mina today to try to make all this happen. a lot of work is going on. The layer 1, the mainnet's been live, and the ZK apps have been live, but on the layer 1 itself, the main work going on right now is on, like, it says WebNode here, but really this is WebNode and RustNode. So this is like a version of Mina rewritten in Rust for like much greater performance. That as well is the same thing that compiles into the browser, so you can access all this stuff, from client devices. And it's going through that first round of public testing right now. The next is these application environments, which I mentioned ProtoKit and Zecco already. They're kind of in like these testing phases where they're usable, but they are moving quickly towards real applications and usage and everything. And I should mention as well, this is probably our best path, these ones, to getting like good DeFi experiences, NFT experiences, et cetera, on Mina that are augmented with zero knowledge proofs in some cases when you want that. Work's happening as well on this client-side proving stuff. Mina Attestations is going through the security audit, as well as there are certain teams working kind of on prover performance as well as mobile proving to make this experience better. As well as there's a lot of work happening actually on layer 1 applications, but there's definitely a big asterisk on these because these are set up as UTXO plus the speed of the base Mina chain itself. These are pretty slow. So this is the kind of thing where if you want access to like a really secure DEX on the Mina layer 1, you don't mind waiting 3 to 5 minutes for your transaction to get proven and go through. This exists actually now, a lot of them, but performance is probably not where it needs to be to really be widely used or deployed. So we'll see. I guess like I hear different things on whether a slow experience is acceptable enough in some cases or not. But I suspect a lot of like this stuff will be much more powerful once it shows up on this, where it's doing 10, 20 plus TPS, instant finality, all of those things. Yeah, and I should mention as well, there's a lot of other applications on the layer 1 too. That kind of both like less infrastructure-y as well as things you can check out as well that are interesting happening on the layer 1. If you want to like kind of see more what's happening in this world and what's going on in all this, I mean, if you really want to just kind of jump into it, there's a CLI for writing. There's a npm. We have on npm tooling for getting started writing ZK apps with ONJS on Mina. So if you really want to, you can just kind of jump in that way. But I think it's probably worth exploring the Navigator grants we have on Mina and Mina Research, where there's lots of people both posting kind of the ideas they have for their projects. Recently, there's like a ZKUSD one. There's one about verifying different Web 2 online payments. There's lots of different interesting ideas going on there. And there's a grant program built around that as well to support people building these new applications. So I think that's another way to check this out. I think as well, like you could also apply to join Mina Foundation or One Labs. Probably makes sense to look at what's actually happening first there more, but there's a lot of really interesting infrastructure happening kind of around this whole stack that we're talking about. We're currently hiring at Mina Foundation particularly for ProtoKit, which is, I think, a very interesting kind of modular blockchain solution space within this whole stack. And really, I think where we're seeing a lot of like this kind of base layer, settlement layer functionality joining up to like application environment, like application level functionality. So very interesting part of the stack and worth checking out if you're interested in this kind of stuff. And of course, we have like a team as well that explores any other interest in new projects, integration support, which we're also always exploring. That's it though. Thank you. You can take any questions, but that's the talk. Yeah.
About nodes.
Yeah.
Running the browser. You find some problems about the RAM that is taking from the node to the browser, and some problems for latency or something like that, because sometimes
Yeah.
you need to maintain open the browser when the node is running.
Yeah. So the current version of this isn't in an extension yet. It's just on a browser page. So you have to keep that tab open basically to stay connected to the chain. So the memory usage actually, I don't think it's that bad. I think it's in the realm of 1 to 2 gigabytes. And so people, it's been acceptable so far. I kind of post on the site here, there's been some people posting creative places to run this on. Like this person ran the Mina node on like a smart fridge, and this person ran it in like their Tesla car. So they've been able, I think it gets away with like on the order of 1 gigabyte of memory usage, and you can run it in some funny places. On the rest, the latency side and everything, Mina itself like isn't that fast of a chain right now. I think the slot time's on the order of 3 minutes. So there's time to get this data around. But I suspect if we really tried to like, it probably will end up depending a lot on WebRTC and its properties. But yeah, we haven't pushed the limit yet on the performance. But it's been fine so far. Yeah.
And do you have any plans for the interoperability part or?
Interop?
Yes, interoperability.
Yeah. I think there's like I guess it's like three main approaches going on right now. For one, there's a centralized bridge being built that bridges Mina and ETH, and that's like actually in DevNet right now. I think it's going to launch the mainnet pretty soon, actually. Yeah. So there's that. Maybe that's like anyway. There's more exciting things. One is an integration with like a aligned layer. So the aligned layer one is more about posting Mina proofs back to Ethereum and other networks, so that you can do your privacy stuff on Mina and then bring it back to Ethereum. I think that's a lot of things are under security audit. I think that was also in that stage right now, and then we'll be on an aligned layer. So I think there's use cases through that. I think another one that's really interesting though is there's a team working on. Have you heard of like the Helios? It's like an implementation of like an Ethereum node that has an SP1 prover around it. And there's a team working on taking that and wrapping it in a Mina proof, and then putting that on Mina, so that you can it's not like settling Ethereum state, but it is like bridging Ethereum state in like a relatively trustless way back to Mina, so you can build a trustless bridge. So I would say like people are exploring stuff, but there's
And about, I like that Mina is on TypeScript, white TypeScript. Do you have any plans for adoption? Like you plan like Web2 developers adopt Mina as another tool like npm package or
Yeah.
something like that?
I think eventually. I think for now, TypeScript is mostly chosen just because it just made it was the easiest way to make it easy to write the client-side things in the browser. There's also a Rust version, though, under development, too, because we know people in the Web3 community, often Rust is better. But I think eventually, yeah, like Web2 is probably a bit far off, but we do want it to be accessible, which is why we went with it. Any other questions?
Yes.
Yeah.
I'm interested in the compiler you just mentioned. So did you build a compiler to compile the TypeScript to the circuits?
No. So you mean like the TypeScript code itself, like a TypeScript compiler?
Yeah.
So no, it's not a TypeScript compiler, but what it is you kind of like it's a library where in the library you're using normal TypeScript run in like Node.js if you're doing server side. And the library, you're kind of building up the logic of your application as you go. The closest thing I could think of is like TensorFlow, if you've used that. Like, I'm not sure. But like basically, I think it's worth just like I think it's like worth the docs like explain it. It's worth checking out the docs for it. But basically, in the library, you're like doing you're slowly constructing your object by doing x.add y dot mul 3 dot if greater than 7, and there's like you do two functions, and it's like it's hard to explain, I guess, like verbally. But yeah.
I guess using the library requires you write some. Basically, it supports some weird way of writing the
Yeah.
program, not the typical TypeScript.
It looks close. It doesn't like we can't override like x plus y, but we can do like x dot add y. And so it does look pretty clean. It's not native, but it looks very close to native TypeScript. Yeah.
And how does you compare your ZK infrastructure with SP1 or RISC-0?
Yeah. I think the main difference is we've primarily built this for circuit construction itself, not for like a VM. So we intend people to like kind of use this TypeScript library to kind of build circuits up to run them client side. And there's lots of like tooling around that is nice. But it's less around VM kind of Rust stuff, if that makes sense. As well as like it's optimized a lot around recursion. And so for example, there's like built into like the language itself really good like library tooling around moving proofs around and having proofs proving proofs and that kind of stuff. Yeah. Kind of like the ZK native like proving functionality is like very baked into the system.
You focus more on the application and TypeScript. They are focused on maybe Rust.
Yeah, like we're not like exactly, yeah, because it's not like a ZK rollup. It's more like writing ZK native circuits for various things. Yeah.
So thank you.
Yeah. Thanks. Any other questions? No. Okay. Well, thank you. Thanks, everyone.